talk about the slope of a line. Now, previously we've looked at some graphs like this, where the rates of change between given points vary. Sometimes they're negative, sometimes they're positive, sometimes they're even zero, no rate of change. But today it's going to be a bit different. Today, let's look at what happens if between 2 points the rate stays the same. We just continue at the same steepness forever. Okay? When you do this, you create a specific type of geometric figure. It's called a line. Now, the constant rate of change that generates this line is so important that it's called the slope. To illustrate the concept of slope or constant rate of change, we are going to do a graph of something my massage therapist told me about. It's called the full body cleanse. This is something that is meant to detoxify the human body and let it kind of restart itself and heal itself. One of the byproducts of this regimen is weight loss. He told me that I will lose 2 pounds a day on this program. Well, naturally, that got me a bit interested, so I started to pay attention. And the only thing that concerns me is that while on this regimen, all you can put in your body is water mixed with lemon juice, mixed with honey, mixed with cayenne pepper. And you have to drink 6 glasses of this a day, and nothing else. Now that sounds pretty rough to me. So before I actually buy into this, I want to see mathematically and graphically what the benefits are going to look like to me. So let's do a math analysis. Okay, let's begin our graph with the horizontal axis as days on the program. And we'll go ahead and calibrate this with the unit being 1 day. But I'm only going to label every other unit here just so that the numbers don't get all smushed together on the graph. All right, and now we're going to calibrate the y-axis as weight in pounds. Okay, we'll go ahead and start at the bottom. We're going to break the axis and start at 116 pounds, which, by the way, is what I weighed when I was in 9th grade. And then we'll just go with a unit of 1 pound per block, but we're only going to label every other one. And we'll take it up until we reach my present weight of 142 pounds. All right, at time equals 0, I weigh 142 pounds, so the first data point goes at A. After 1 day on this program, I should lose 2 pounds, which means I'll weigh 140, which would be data point B. After 3 days on this program, supposedly I'm going to lose more. I'll go down to 138, and that'd be point C. And after 4 days, I should go down to 136, and we're going to call that data point D. Something's happening. It looks to me like we've got the same rate of change between all of these points. Let's check it. Take a straight edge, and if you've graphed it very, very well, doggone it, that straight edge does pass through all of these points. So we are looking at a linear situation that has a definite slope, and it is a negative slope. All right, now that we've drawn the line, let's start describing it. Let's find its slope. You can do this actually graphically by looking at the graph. So let's do that. All right, let's take a look at the slope from point A to point B. Okay. Or the slope of this section right in here. Okay. Remember, slope is rise compared to run. Okay. So, in this particular instance,
We're starting at A and we're going to B. Now we're going to describe that with vertical rise motion and horizontal run motion. Now in this case, to get from A to B, we're going to go down one and then one more. So we're going to go down 2 blocks and we will run 1. So the slope here will be -2 over +1. Now there's another way to look at this same segment as well. We could start at B and go towards A. Right? It's still going to be the same segment and we should still get the same slope. But it's possible to look at it as a rise up and a run in the negative direction. And that would look like this. We would be going up 2 and then over to the left in the negative direction 1. So in that case, we would get +2 over -1. And of course, that has the same reduced value that we had over here. Both of these reduce to a slope of -2. Now, we did mention earlier that slope is a constant rate of change. So we can pick any 2 points on this line and do this rise over run activity, and we should come up with -2. So let's select B and D. All right, let's travel from B to D and see what rise is involved. In this case, if we start at B, we'll have to go down to get across from D. So that will be 1, 2, 3, 4 blocks in the negative direction. So I will put -4 right there. And then 1, 2 blocks of run in the positive direction. Well, as you can see, -4 divided by +2 does indeed, once again, reduce to -2. And you can notice that the same thing will happen if we go from D over to B. Here we would rise in the positive direction 4, I'll put that right here, but we would run then in the negative direction 2. So that would be a -2. Again, this reduces to -2. So no matter how we do it, we always get a slope of -2. I was 132. Okay. Let's say all we have is these 2 pieces of data, and from those we want to determine the slope or the rate of change. Well, we've done this before. If you're given 2 pieces of data and you want to find a rate of change, okay, it's just the same thing. It's, excuse me, that's 9. Rise over run, or as we spoke of before last week, delta y over delta x. This means the change in y over the change in x. Okay? And sometimes your change in y is going to be positive, sometimes it's going to be negative. It depends whether you are decreasing or increasing. Okay? And if you're flatlining, the change in y will be 0. Okay? Now, mathematically, the way we determine this is by taking the later y value, y sub 2, and from it subtracting y sub 1. Okay? And the change in x is taking the later x value and from it subtracting the earlier x value. All right, so let's do that. Okay, the later y value was 132 pounds. That's what I weighed after 5 days on the program. If I subtract from that the earlier weight of 142, you'll see that I've lost 10 pounds on that. All over later days on the program minus earlier days on the program, and therefore you can see here that I'm going to get -10 over 5, which by George, by Jingo, reduces to -2.